our 9.1 support. So the 9.1 support was getting us ready for the 9.1 college algebra. So for the support, I'm actually going to do problem number 2, but you'll do problem number 1 pretty much the same way. I just wanted to do the tougher of the two. All right, y'all, let me let one in real quick. Get sure. So for this 9.1 support, they want us to find the indicated outputs for f of x equals 4x squared minus 5x. And then they'll give you what they want each time as you go through it. So this one wants me to find 4 values, actually. So they're starting me off with f is 0. So remember, f of 0 wants me to put a 0 in for every one of the x's on my function here. So putting zeros in, I would have 4 times 0 squared minus 5 times 0. So it looks the same other than my 2 zeros I put in. So y'all, if I'm following order operations, exponent first. So bring down to 4. 0 squared would be 0. And I just brought the other part down because now I'll do all my multiplying. So the 4 times 0 is 0. Minus 5 times 0 is 0. So y'all, looks like f of 0 is 0 for that one. So once I put in that answer in MATLAB, they pop out with a f of 3. All right, so f of 3 now wants me to put a 3 in for both of these x's. So I would have 4 times 3 squared minus 5 times 3. All right, y'all, once again, exponent first. So bring down that first 4. 3 times 3 gives me 9. And then I'm just bringing everything else down. So I'm just doing the exponent first on these every time. Now I'm going to multiply the 4 times 9 and get 36. Minus the 5 times 3 is what, 15? So that means now f of 3 is going to be 36 minus 15, which is 21. So I put that answer in. MATLAB says, well, hey, let's try a -1 on this one. Now, this -1, I'm still getting people on this one, especially if you do this on the calculator. I'll bring down that 4. And I would definitely use parentheses for my multiplication on this because now my -2's in parentheses like I need. I'm going to square that. Minus 5 times my 3. So exponent first again. So bring down that 4. Remember, anything I squared will be positive.
Should that
So
be
negative?
Should that be -2 instead of the 3 with the -5?
Again. Oh, right here. My bad. My bad. I see what you're saying. -2 right there. Well, I get to talking and I was probably looking at that 5 to the 3rd there and put a 3 there. So y'all make sure it's 4 times -2 squared minus 5 times -2. Thanks on that, Dan. I get to yakking and writing different things, so y'all keep on me. All right, y'all. So the -2 squared will be a positive 4 there. Then I'm just bringing all this down. All right, so let's multiply this. 4 times 4 give us 16. Now notice here, this is like multiplying a -5 times -2. So that'll be what, a positive 10. All right, y'all, so f of -2, if I add them together, gives us 26. So look, they hit me with a 0, positive number, negative number. Now on this one, y'all, they want me to find f of r plus 2. Now this one I'm about to do is really going to get you ready for the college algebra part of this. Because everywhere they got an x, we're going to put r plus 2. So 4 times r plus 2 squared minus 5 times r plus 2. All right, y'all, let me let one back in there. So we know we're going to do the exponent first. So I'm going to bring down that 4. Now, where I'm getting a lot of people is what they're about to put in these parentheses. Remember, when we got a binomial like this, r plus 2 squared, you can't just shoot that exponent through these parentheses. You're going to have to work this sort of like on the side. Because that r plus 2 squared is the same thing as writing that twice. So when you got binomials like this being added or subtracted, you got to FOIL this, okay? So this will not equal r squared plus 4. We're going to have to FOIL this and see what we get. So r times r gives us r squared. R times 2 gives us a 2r. Then we'll do the inside. 2 times r is 2r. And then the last ones will be the 2 times 2. That gives me a 4. And I'm going to make it a little shorter because I got like terms in the middle. So bring down our r squared. Plus 2 and plus 2 gives me what? A 4r in the middle. And then plus my 4. So y'all notice when you got a binomial squared, it's going to end up being a trinomial, okay? So let's put that right here, r squared plus 4r plus 4, and then we'll bring down our minus 5 times that r plus 2. So now the exponent is done. Now we'll multiply the 4 through the first parentheses, the negative 5 through the second one. Since that's being subtracted, we do have to distribute that minus. So the first one, 4 times r squared is 4r squared. 4 times 4r is a 16r. And then 4 times that 4 gives me a 16. So I'm done with the first parentheses. Now let's work on this. Negative 5 times r is a negative 5r. Negative 5 times 2 is a negative 10. So, y'all, I would ask y'all, can I actually go further on this?
You can minus the 10 from the 16.
Yes.
Okay, so the 10 and 16 will be like terms.
And negative
16r minus 5r.
Okay, the r's are going to be like terms. So what I'm going to do, I'm just going to put it in descending order. So I'm going to bring down that 4r squared. So y'all, 16r's minus 5r's. What's that? 11r. And then what'd y'all say? The 16 minus the 10?
Plus 6.
Plus 6. And y'all, no more like terms, so we're going to stop right there. So this type of stuff right here, that r plus 2 squared, it's getting you ready for what's about to hit us in that college algebra 9.1, okay? And then it wanted me to also remind you that r plus squared, when I'm doing a function value of r plus squared, I'm replacing every single one of these x's with the r plus 2, okay? All right, y'all, so let's play with some 9.1 college algebra. 9.1 deals with what we call the composition of functions. So what's going to happen in this section, instead of putting a number or a variable into my function, I'm going to put a whole function into the x values of another function. All right, y'all, let me let one in real quick. So let me show you the two things that are terminology. So first, we got f compose g of x. Now, y'all, let me tell you, that little thing in between the f and g is not a dot for multiplication. That's like a little circle, and that little circle lets me know that this is the composition operator. So, y'all, what this, I call this fog because it looks like FOG. But F compose G really means F of G of X. So notice now for my F function, I'm putting this whole G of X in for its X's. So for this kind of setup, what we would do, we would work the G of X first. If needed. Then we would put that value into the f of x. Then put that value into our f of x. So this is mainly if we're given numbers. I would plug it into my g of x function first, see what that number it gave me. And then that number I would plug into my f of x equation. Now, guess what? This will go the other way. They could give me a G compose f of x. So if they gave it to me in this order, G of f of x, that's like a G of our f of x. So this time we'll be taking the f of x function, seeing what we get, and then putting that into the G. So writing this one out, we would work f of x first, if needed. Because you'll see later, the first three are going to give us numbers. The second three, they just give you variables, okay? All right, then we would put this value into our G of x. So it's almost like I'm working order of operations. I'm starting with the innermost parentheses and working my way out. Start with the f of x and then plug that into our G of x. So they're not too bad once you see us play with some of these. So y'all, let's let f of x equal negative 3x minus 1. G of x is going to equal x squared minus 2. They want us to find f compose G of a negative 3. All right, so if I was going to write this one out like up here, this is actually going to be f of G of negative 3. So what do we say up here? We would work G of x first. Well, here's g of x, but guess what? They're giving me a number for my x. So the first thing we got to work on this, first we got to find what is g of -3. Well, g of -3 is going to equal this g equation with us putting a -3 in place of that x. So we would definitely put parentheses around that -3, square it, and then -2. That's all, y'all. Let's hit that exponent first. -3 times -3 gives me a 9 minus 2. So this now tells me that g of -3 equals a +7. So what do we say? We work g of x first, which we did. Then we're going to put that value into the f of x. So that means we're going to find what? F of 7. Because that's what this g of x, where'd it go? That's what this g of x equaled when I put in that -3. So f of 7 wants me to take the f equation and put a 7 in for that x. So -3 times 7 minus 1. All right, y'all. So this one we got to multiply first. So there's going to give us what? A -21 minus 1. -21 minus 1 gives us a -22. All right, so -3 went into the G. That answer went into the F. So this one, we're going to sort of turn it up just a little bit and show you where that support came in on this one, okay? So y'all on this one, I'm given f of x equals 3x plus 4. My g of x is going to equal x squared minus 3x minus 5. We're going to find, now watch this order, we're going to find g compose f of a 6. So this is the same as finding g of f of 6. So I wanted to give y'all at least one going each direction. So this one, I got to find f of 6 first. Once I get that f of 6 answer, I'll throw it into my g. So here we go. First, find f of 6. All right, so f of 6 will equal my f equation, putting a 6 in for the x. So y'all, that is 3 times 6 plus 4. And what's that? 18 plus 4. So it looks like my f of 6 is going to be 22. So now that we know this f of 6 equals 22, we're going to find g of that 22. So you see, these are pretty much two-step problems. You got to find one function and then go after that other one. Oh, y'all, this is going to be big. I got a 22 squared minus 3 times 22 minus 5. So one of y'all figure out what that 22 squared is. Ooh, let me think. That's what
Is it 484?
484.
484.
Uh-huh. And then minus 3 times 22, that's not bad. That's what, a 66. And then minus my 5. Ooh, so let's see. These two added give me negative 71. 484 minus 71. That's what, a 413.
13.
There you go. So like Math Lab wanted the negative 22 here. Math Lab wants the 413 there. Okay. So be careful. You might get a big number here. Just square that thing and move on. All right, so to do the last of this 9.1 homework, we got to learn about what I call interval notation. All right, y'all, so interval notation. And y'all, I'll tell you what, in math, we get lazy and we're getting tired of writing out that X, such that X is a real number and X cannot equal whatever number. So we get tired of writing all that. So we use what we call interval notation. So I'm going to start out by telling you how we represent all real numbers. So to represent all real numbers, we use, so interval notation, we use parentheses. So y'all, if I went out to the negative side of the numbers and I kept going out the negative side, if I kept going forever, I would be headed towards what we call negative infinity. Now, if I went out the positive side and I keep adding and adding and adding, I'm headed off towards what we call positive infinity. So this is now how we're going to represent all real numbers in interval notation. I can go all the way out negative infinity. I can go all the way out positive infinity. And every number works for some of my functions, like the straight line ones we did and parabolas and all those. But what we got to now do is figure out, how do we exclude a number? So to exclude numbers from the domain, we use parentheses and what we call the union. This union right here means and. Okay. Now, I'm going to refresh you on why we're using curvy parentheses. Back when y'all was playing with number lines and all that, you should have learned that when I use curvy parentheses around a number, it excludes that number. If I want to include a number, we would use those brackets. Remember the square brackets? That includes a number. But if we use parentheses, that means that we're excluding a number. So watch this. For example, to exclude any number A, we would write they all start at negative infinity, okay? So every one of your domains will start at negative infinity. But now I'm going to exclude this number A. So I would say I'm going from negative infinity to A. Now the A has a curvy parentheses because remember, the parentheses means I'm excluding the A. Now I use the union. And then I start on the right side of the A. But remember, it's still got a curvy parentheses. So by using these parentheses, I'm telling my domain that it cannot equal A. And y'all, from the A, I head off towards positive infinity. Then y'all, the reason infinity does not have a bracket is because there's no ending on infinity. So we automatically use the curves on it no matter what. So to exclude a number, if I exclude two numbers, I'll have two unions. If I was to exclude three numbers, hell, I'd have three unions, okay? All right, y'all. So the reason I had to show y'all that was for this next example. In this example, we're going to find f compose g of x and g compose f of x and the domain of both. All right, y'all, let me see what my chat's saying here. All right, Diamond, you good now? Can y'all see me, Diamond?
I can.
Okay.
Oh, okay. It's two diamonds, so it wasn't me.
I seen that was Diamond Butler, actually, right? You're Armstrong, ain't you?
Yes.
Okay. All right, y'all. So, but notice, find f of g of x. They did not give me a number this time. So watch what we got to do. So our f of x is going to equal x plus 2. G of x is going to equal 3x squared minus 2x's minus 1. So I got to find f of g of x, and then I'll figure out its domain. Then I'll find g of f of x and figure out its domain. So I guess we're starting with our fog. F compose g of x will equal f of g of x. But y'all notice, they didn't give us a number this time. That means we're going to have to take this whole g of x. We're going to take the g of x function and put it into the f. So y'all notice, my f is x plus 2. Remember, this is going in for my x, because we're putting this whole g equation in for this x. So we're going to have 3x squared minus 2x minus 1. And then notice, the rest of f of x is a plus 2 at the end. All righty. So now, all I can do to this is add like terms.
Where'd you get that 2 at the end?
Do what now?
Where'd you get that 2 at the end?
Oh, because remember, f of x is x plus 2. So remember, I put the whole g right here into the x. But remember, there's still plus 2 after that, right?
Right, but I didn't see the x in front of the 2. That's what threw me off.
So here's my x plus my 2.
Oh, okay, yeah, gotcha.
Okay. So now all y'all can do is add like terms here. So it looks like I'm going to get what, a 3x squared minus 2x. And then that negative 1 plus 2, that's going to give me what, a positive 1. Now, a lot of these I've been seeing have been ending up like a negative 2 plus 2. If you get a negative 2 plus 2, then it would cancel and you just have the 3x squared minus 2x. So this is the first one I've actually done today where I actually got a number on that at the end. But y'all, this is f of g of x. No more like terms, so I cannot go no further. So what would be the domain of my f of g of x? Remember, I had a 3x squared minus 2x minus 1 plus 2, simplified to a 3x squared minus 2x plus 1. So the first question, y'all, is there any restrictions on this domain? What do we not see here? Or here?
Is it a fraction?
Yeah, I don't see no fractions there to y'all. And remember, at this point, if we didn't have a fraction, we said our domain would be all real numbers. So here we're going to write all real numbers as negative infinity to our positive infinity. All right, then they said, hey, I want you to find g of f of x. Remember, that's going to be g of f of x. So y'all, since I didn't get a number, I'm going to take this f of x function and I'm going to throw it right into the g function. So y'all look, here's my g, 3 times x squared. So I got 3. So y'all, what's going in place of that x?
The whole first equation.
The whole first equation. So that's an x plus 2. And that thing's getting squared. And then it's minus 2. And y'all look at that. I got another x. So what's going after this 2? Is another one of those x plus 2's. And then at the end is a minus 1. So I put the f equation in for both of these x's. Now, why did they kill me in support with this thing? So I'm going to bring down the 3. So guess what? I got to figure out what's going in these parentheses. You know, the exponent's first priority, but it's behind that x plus 2. So I got to do my side work again. Remember, x plus 2 squared is really a x plus 2 times the x plus 2. So we'll figure out this and we'll throw it in our parentheses, okay? So x times x is an x squared. X times 2 is 2x. 2 times x is 2x. And y'all, 2 times 2 is a 4. So remember, I said a while ago that when you square these binomials, it always ends up as a trinomial. Because we got like terms in the middle. So x squared plus a 4x plus 4. So you're always going to end up with a trinomial. And we'll put that right here. Minus my 2 times x plus 2 minus my 1. So the first thing I did was just make sure I got rid of that exponent. Now, the first parentheses, we're going to distribute our 3. Second parentheses, I'm going to distribute the negative 2. So this is really why we did that support, okay? So multiply everybody by 3, you get a 3x squared plus a 12x plus 12. Multiply these by negative 2, so you get a negative 2x minus 4, and then at the end is a minus 1. All right, now guess what? Add like terms, but I'm going to go in descending order, so I'm going to bring down that 3x squared. I got a 12x minus a 2x. So what's that? 10x. Then I like a 12 minus 4 minus 1. So that's what, an 8, and then 8 minus 1. That's going to give us positive 7. So I've seen some of these today canceling out the numbers also. So just be prepared when you add like terms. Some of these might go away for y'all, some might stay. All right, so y'all, this is what Math Lab wants on this. But notice, G of f of x looks like G with some big X's. F of G of x look like F with a big X on it, okay? All right, any guesses on my domain?
All real numbers.
All real numbers. So negative infinity, positive infinity, and be done.
4 pins remaining. So how many did he knock down? Started with 10 pins. So if we subtract the pins that are left, we'll find the number that was knocked down.
All righty, y'all. So let's do another one.
Yay.
And I'm going to guarantee you this one's not going to say all real numbers, okay? So I'm still going to find F composed G of X, G composed F of X, and guess what? The domain of each. All right, y'all, so let's see here. F of X is going to equal 3 over 1 minus 2x. So bam, a fraction right off the bat. And if that wasn't bad, they come in and said, well, let's let G of X equal 1 over X. So y'all, they throw 2 fractions at us. So let's play with the F of G of X. That's going to equal F of, or G of X. So once again, we're going to take this G of X equation and throw into the F. Remember, this whole G goes into the F. So F is 3 divided by 1 minus 2. And y'all, what's going in right there in parentheses?
1 over x.
1 over x.
There you go. So y'all, let's see. Right off the bat, I got a fraction right here. So this little x on the bottom, what can that x not equal?
The 0.
It cannot equal 0. Because if I get a 0, that makes that undefined, and undefined can't multiply by 2. All right, so we now know what x cannot equal off the bat. So y'all, here's the trick on this one. Notice I got a fraction with a fraction inside of it. This is called a complex fraction. And what I got to do is eliminate this little fraction right here. So to eliminate this fraction, I'm going to multiply top and bottom by that LCD, which is the x. So I'm going to multiply top and bottom by the x to eliminate that fraction. So eliminate the fraction. All righty, so let's multiply the top and bottom by x. Now remember, when I multiply the bottom, I got to distribute that x, okay? So on top, I'll multiply the x times the 3. On bottom, I multiply the x times the 1 minus my 2 times 1 over x times that x. So y'all, what happens over here? You see how I got this x on top? And I got this x on the bottom? Y'all, guess what? These x's will cancel. So notice on the top, x times 3, we're just going to make that a 3x. So y'all, what would I get on the bottom if I cancel these x's out? What do y'all
You'll
think?
have 1 minus 2 with the exponent of x. I mean 1.
Well,
Is it one
here,
minus two?
so
Debbie.
here, x times 1 will just give you an x. And then you're perfect over here because those x's are gone. And 2 times 1 just made that a 2. So by canceling out them x's, everybody else basically got an x. But y'all, this looks like a normal fraction. I got a numerator and a denominator. I no longer have this extra fraction, okay? So here's a question. What can this x right here not equal? So what would make that
Is it
equal?
2?
So what would make that equal 0 down here if x was a
2.
2? There you go. So notice I got two numbers that this domain can't have. I can't be 0 here, and I can't be 2 right here. So y'all, let's write that domain. It will start at negative infinity. Now you got to go in order left to right. So between 0 and 2, the first number I would hit going from the left would be my 0. Now remember, I'm kicking that 0 out, so I've got a union around it by putting parentheses, my union, and then starting my 0. So by unioning around 0 with the parentheses, that kicks it out. So from 0, we're cruising along the x's until we hit what?
2.
2. So we're going to union around our 2. And then how about from 2 to what?
You said 2 to what?
Positive infinity.
To infinity. So they all have to have the negative infinity on the left, positive infinity on the right. And we just union around every number we kick out. So y'all, if I'd had 3 numbers, I got to have 3 of those unions, okay?
Oh, I see. Okay.
All right, y'all, here we go. G of f of x. That's going to be the other way around. I'm going to be finding g of f of x, which means we'll take the f of x equation and put it into the g of x equation. So here's g, 1 over x. So this will equal 1 over x. Well, y'all, what's the x going to be?
A 1.
Well, what's my f of x?
Wait, 3 over
Oh, 1 over.
1.
Yeah.
There you go. 3 over 1 minus 2x. So remember, I got a fraction inside of a fraction. So we're going to play with that in a second. But what can this x not equal? So this is a little trickier, right? So what you could do, set that 1 minus 2x equal to 0. Solve that for the x, and that'll tell us what it cannot equal. Y'all, I'm just going to subtract 1 from both sides. I get negative 2x equals negative 1. Then I'm going to divide both sides by negative 2. So that cancels. I get an x. Remember, negative divided by negative makes that a positive 1/2. So that's telling me if I do 2 times 1/2, that gives me 1. And then 1 minus 1 would make that 0. So we know our x cannot equal 1/2 for that part, right? But y'all, any other number works. Guess what? We now need to simplify this because I got this fraction inside of my fraction. So remember, while go to fraction, I was worried about had an x on the bottom. So I multiplied everybody by x. This one has a 1 minus 2x on the bottom. So what we're going to do here, we're going to multiply top and bottom. By 1 minus 2x. Because, right, that's the denominator I need to get rid of. If I could get rid of this 1 minus 2x on the bottom, this becomes a regular fraction. So we're going to multiply the top. 1 minus 2x times 1. We're going to multiply the bottom. 1 minus 2x times 3 over 1 minus 2x. So since this whole thing was my denominator, that's why I had to multiply the top and bottom by that. But y'all, what happens on the bottom? They cancel.
They cancel out.
Bam, bam. Now, on the top, nothing cancels. So 1 times anything is that anything, right? So that's just going to be 1 minus 2x on the top. What's on the bottom?
3.
3. Everything else canceled out. So y'all, let me ask you this. On this fraction, we're not worried about any numbers because there's not an x in the bottom. No matter what I put in up here, that'll always be 3 on the bottom. So we don't have to exclude no numbers from this one. But remember, up here, we did have to exclude that 1/2. So here we go for our domain. And then y'all notice, this looks like a regular fraction now, right? A numerator and a denominator. All right, y'all, so where will my domain start?
Negative infinity.
All right, you're cruising from negative infinity until you hit what?
1. No, -2, isn't it?
Oh, remember, oh, you're not on that. We're just doing this one right here. So
1/2.
we kicked out on this one was our
1/2. Yeah.
1/2. All right, y'all, then union that from 1/2. Now, since I only had one number on this one to worry about, from 1/2, I'm heading towards.
Positive. Yeah.
There you go. So y'all, that's the trick. This is what the trickier of the ones doing this stuff, okay? Just remember, the only goal on these is to eliminate all these little extra fractions.
Could you show that whole page before you remove it?
The whole page up on the top?
Yes, sir.
All right.
She is a worker whose job she has stated is to talk to men for money, and she found out that one of her clients was actually Ashley's husband. She started making claims saying that she wasn't going to come out and address anything. However, she felt that Ashley was making posts shading her, such as having like a BBL done, and Ashley made a statement about her daughters.
And now we'll play with little 9.2 support real quick, and then we'll knock out the 9.2 college algebra. So are y'all good on my page?
So this is support, right, Mr. Eugene?
Well, this was 9.1 just now.
Okay. Ooh, Lord. Okay.
Doing the composition stuff was my 9.1. I started out by doing one support problem earlier.
Okay.
So now I wanted to do a couple 9.2 support. Stuff that'll sort of help us for the 9.2 college algebra. So this first example says solve 4 over z plus 3 equals 3 over z minus 6. Now, these aren't bad when you got a fraction equal to a fraction. This is where we do what we call cross multiplying. So to cross multiply, the top of one fraction multiplies by the bottom of the other fraction. That means I'm going to have a 4 times z minus 6. That'll equal the product of the other top times this first one's bottom. So that'll equal my 3 times my z plus 3. So y'all, that's how you get rid of fractions. When you got one fraction equal to a fraction, cross multiply. Now here you're going to distribute the 4 so that you get a 4z minus, what's 4 times 6 is 24. Over here, distribute the 3. So 3 times z is a 3z. 3 times 3 is a plus 9. So y'all, let me tell you this. At this point, you can solve this in 2 steps. First thing, start with the variables. Always move the smaller variable to the side of the larger variable to keep them positive. So I'm going to subtract 3z from both sides. 4 minus 3 is going to leave me 1z minus 24. Over here, them things cancel, and all that's left is my
Okay,
9.
hold on, Miss Eugene. I can barely hear you because somebody's TV is in the background and it's loud. I've
All
been
right,
trying to not
one
say
here.
it. But they TV
And,
loud.
all right, so yeah, I had to let one back in anyway. All righty, so now get the z by itself by adding 24 to both sides. And y'all, that z comes down. That cancels on the left side. And let's see, 9 plus 24, that's what, 33. So the main thing, to solve an equation with a fraction equal to another fraction, cross multiply. Next thing they want us to solve is the square root 4x minus 5 equals 1. So y'all, what does this radical do? It takes a square root. Now, here's the thing about square roots or radicals. Anytime you got a radical like this and there's not a number right here in that notch, we automatically assume that number to be a 2, which stands for square roots. So to undo a square root in an equation like this, you always want to get this square root by itself. Now, to make that radical go away, we do what we call square both sides. So I square this side and I square the other side. What I do to one side, I do to both sides. But y'all, exponents cancel radicals as long as the exponent matches the number in the notch. Now remember, since this one don't have a number in the notch, it's a 2. So y'all, that cancels out the radical, giving you a 4x minus 5. And over here, 1 squared, 1 times 1 is a 1. So look at that. The radical's gone, so now we're just solving that for the x. So move that 5 over by adding 5. I get 4x equals 6. Divide both sides by 4. So y'all, that gives me my x. Uh-oh, you can't divide that, but one of y'all need to simplify that.
3 over 2.
3 over 2. There we go. Now let me show you what I got here. I'm going to do one with more stuff in it. How about a square root of 5x plus 6 equals 13. Notice I got another radical again, but y'all, before you do the squaring stuff, this radical has to be by itself. So we got to move that 6. So to move that, because see, the 6 ain't under the radical, okay? Over here, this -5 was under the radical, so I can't add it to both sides. I had to get rid of the radical first. But this plus 6 is not under this radical, so we gotta subtract that 6 so that we can get this radical by itself. So my square root of 5x, let's see, 13 minus
7.
Now, what exponent do I want to raise both of these sides to?
Is it 2?
It's a 2. There you go. So y'all was nice. That canceled the radical, so all that's left is the 5x. But now, 7 times 7, what's that, 49? And then look at that, my last step, divide by 5.
Hold on 1 second, Mr. Eugene. Did you not, on the radical, the 5x radical squared, did you not do anything to it? Because you just brought it down as a 5x.
No, this exponent 2 canceled out that radical.
Got it. Okay.
There you go. Y'all, let's see. 49 over 5, I think that cannot reduce, right? So our final answer will be the 49 over 5. All right, so I wanted to do one more with a cube root. See what we do to this. Cube root of x plus 6 equals 2. Y'all, guess what? That 6 is under the radical, so we can't move it. So how can I get this x plus 6 out from under that cube root?
Do you divide? No.
No, get rid of that radical. How did I get rid of these radicals?
Oh, square it.
Oh, you're so close.
Would you
Cube it.
Cube
it.
There
Okay.
you go. Which means this side I'm going to cube also. So match there you go. You had to match the number in the knot. This is what we call the index. You got to raise it to whatever exponent matches that, because that now cancels all that out. All that's left is that x plus 6. Right, then we got to figure out what 2 times 2 times 2 is. So 2 times 2 is 4, times 2 is 8. But we're happy because that thing canceled out that radical. All right, y'all, one more step would be to what, subtract your 6. So that's giving me what, an x equals 2. So cross multiply the fractions. Get your radical by itself. Once you got the radical by itself, this exponent will match what's in that index. And like we said, when there's not a number in the index, put a 2 there, okay? All righty, y'all. So that gets us ready for 9.2. And 9.2 is what we call inverse functions. I will say it's probably not as bad as doing the composition stuff. So first we'll learn about what inverses are. And then we'll look at what we call the horizontal line test. And then we'll deal with the inverse functions. So on this one, they want me to find the inverse of the relation. Now, if you remember when the very first, I think it was in the second section we did 2.2, we had to do the inverse. We had to find whether a relation was a function or not. And I had the domains and the ranges and drew the arrows. Well, another way that I can represent a relation is by the actual ordered pairs. So I'm going to do a -9, 2 for my first ordered pair, a -7, 7, a -2, 9, and finally a 5, -5. So y'all, here's the trick on this problem. To find the inverse of the relation right here, I got 4 ordered pairs. To find the inverse, we simply swap each X and Y. So our answer, they'll give you the fancy parentheses, but you have to draw the regular parentheses. So remember, these points, what's the -9 and what's the 2? Well, the -9 is like the X's, and the 2 is the Y's. Remember, ordered pairs have the X and then the Y. So if we swap each X and Y, what's my first point?
2.
2.
-9.
-9. All right, continue on.
+7, -7.
All righty. 2 more to go.
+9, -2.
Uh-huh.
-5 and +1. I mean, +5.
Perfect.
Sorry.
So all we did was swap each of these X's and Y's around, okay? So remember, inverse is like the opposite of something. Now, what if I said this? Find an equation. Oh, that's an N there. Find an equation of the inverse relation. And they're giving me X to the third Y equals -7. So what did I do here is the same thing I'm going to do here. I'm simply going to swap my X and the Y. So if I swap the X and the Y, what's that going to give me?
Y to the third power X equal -7.
Damn, that's it. So we're really wanting y'all to realize that when I do the inverse stuff, I'm simply swapping X's and Y's, okay?
So why did you swap the exponents instead of doing like y to x3?
Because we're leaving the exponents the same for when we do the swap. So if the X was being cubed, that's going to make my Y being cubed. Okay.
No, I think he's asking like, because I kind of got the same question. Like, so instead of for the reverse, we did y3x. Why wasn't it yx third?
Because
so saying y come to 3 then follow the x.
Remember, I don't want my exponent to follow the X, because if I put up yx3, well, hell, that's the same as the x3y, right?
Yeah, you're right. Okay, got it.
It's just in different order, but it didn't actually swap the stuff. We don't want the exponents to remain the same because all we're doing is rewriting it, but we're not giving our inverses, okay?
Okay.
All right, so our horizontal line test. So for a function to have an inverse, that means the function has to be 1 to 1. So the horizontal line test, now what I mean by 1 to 1 is that every Y value can only have one X value. Remember, vertical line checked for functions, and that meant that every X could only have one Y. But remember, if it's going to be 1 to 1 and have an inverse, then all the Y values can only have one X value. So this horizontal line test says if a horizontal line can intersect a graph more than once, the graph is not one-to-one. And remember, by one-to-one, I mean each y can only have one x value. Okay? So, and that makes sense. If I'm swapping all these x's and y's around, then it's got to be one-to-one because I'm swapping all those values, which means the new x has to have only one y value, okay? So just think about it because you're swapping them all around. So they're going to give you some pictures and they're going to say, hey, use the horizontal line test to determine if one-to-one. All right, here's my X's and my Y's. Now this one, they're giving me a graph that's sort of going uphill, left to right. Is this graph one-to-one? Well, y'all, we're going to do our vertical line test. I mean, our horizontal line test. Remember, horizontal lines cut across like that. Intersects it only once. I could go right there. Intersects it only once. I can go right here. It only intersects it once. At the bottom, I can go across. Only intersects it once. So this one, since it only intersects my graph anywhere on these horizontal lines, one time, this one would be a yes. It is one-to-one, which means I could find the inverse, okay? What about an upside down parabola? Is this graph one-to-one?
Yes.
No.
All right, so let's see. Let's shoot a horizontal line right across there. Oh, y'all look, it hits it here and here. And in a lot of places, I'm going across hitting it twice, right? So remember, since it intersects more than one time, this would be a no. But we got tricks. On this kind of problem, they would probably restrict the x values so that anything on this side is not included in the domain. So they do weird stuff if you want to actually be able to do them kind of problems. So y'all, let me try one more. Let me fix my paper. Oh, my X and my Y. Whoops, let me pull up. So for this one, my graph is going to come up. It's going to cut through the middle, and then it's going to curve up. Is that graph one-to-one?
Yes.
Yes.
Yeah, because I can shoot lines all the way across this. It's not going to intersect it more than once anywhere. So good job, y'all. It is definitely a yes.
And you said the rule to that one is not intersecting more than once, correct?
If it intersects it more than once, it's not one-to-one. And remember, that's what that horizontal line test, if it intersected more than once, it wasn't a function. So just remember, on any of these tests, whether it's vertical line or horizontal, It's always going to be yes on those if it's only intersecting at once. So y'all, we're wanting to find inverse functions. So how to find an inverse function. Now, the notation that we use to represent inverse function is f negative 1 of x. So f negative 1 of x is what we use to represent our inverse functions. So here you go, step 1. Remember, a function is going to be something like f of x equals, say, 3x plus 2. But what does the f of x really represent? It's really the y, right? So my first step, I'm going to replace the f of x with a y. Because remember, I want a y there when I start solving equations. I don't want that f of x in the y. So now guess what? I'll have my y variable and my x variables. What do y'all think I'm going to do with them x and y variables? And think about, what did I do earlier on them first few problems? I think I heard it, but I didn't hear you.
You're gonna swap them.
I'm going to swap them. So I'm going to swap
The inverse.
the x and the y. All right, y'all. So guess what? I swapped my x and y. Now I'm going to solve for the y. So I swapped the x and the y. Now I solve for the y that I now have. And y'all, once I solve for that y, I'm going to replace the y with my inverse notation, which is f negative 1 of x. So I'll have my original f of x equation, and then I'll have my new inverse equation. So replace f of x with y, swap the x and y, solve for the new y, and then replace that y with this notation. Now, y'all, MathLab will give you this part. MathLab's going to give you this. All you got to do is put your answer in the blank. You don't have to write that. MathLab was actually nice on that, I guess, and they actually write it for you. Now, check these out. They say, determine if 1 to 1 then it says, if it is 1 to 1, find its inverse function. Now, y'all listen. These start on number 6. No, not 6. These start at number 7. And I'm going to tell y'all, to save y'all time, every single one of those homework problems starting from 7 and going all the way through are all 1 to 1. Okay? So you might as well save your time and just roll on through them. So I'm going to do one like number 7. Number 7 has f of x equals x plus 2. So y'all, what's the first thing I said I'm going to do to this?
Change f of x to y.
Change that f of x to a y. So we got y equals x plus 2. All right, now what are we doing?
Swap the X and the Y.
Swap the x and the y. So I'm now going to have x equals y plus 2. So now I'll write that out here. Replace f of x with a y. Then you said we're going to swap x and y. And at this point, we're going
Solve
to
for y.
solve for the y. So if you're going to solve that for the y, what's your one move you need to do?
Switch the X and the Y.
Based
Or
on
no.
Well,
the 2.
subtract 2, because all you want to do is just get this y by itself, right? So to get that y by itself, I would subtract 2 from both sides. So here, not like terms, that's just going to be x minus 2. But y'all look what I got over here. The 2's cancel. All that's left is the y. So now if you want to put it in what we call standard order, the last step was replace that y with f inverse notation. So in math lab, you'll have the f -1 of x equals, all you're putting in this box is what?
Would it be
X.
X minus 2?
The x minus 2. Okay, so once you pretty much got it solved here, that's going right in the box and you're done. So notice, the original function was the x plus 2. Its inverse was the x minus 2, okay? And you'll notice these opposite operations a lot on these problems. All right, so let's try some more of those. Whoops, I had it back on that one. All righty, so what if I do, how about this one? This is like 8. F of x equals, all right, let me get my camera back up. F of x equals 5x minus 6. So we're going to replace f of x with a
Y.
All right, what y'all want me to do?
Swap X and Y.
There you go. Now you're going to solve that for that y. So remember, we can add a y on the right side. That's cool. I just want to get this 5y by itself. So let's come in and add 6 to both sides. So I get an x plus 6 over here. And y'all over here, all that's left now is that 5y. But I want you to turn the 5y into a 1y. So we're going to come in and divide both sides by that 5. Now, we cannot simplify this. So that's going to stay a x plus 6 over 5. But y'all look at that on the right side. 5 divided by 5 gives me a 1y. So my f -1 of x, since we couldn't simplify that, it's going to be a x plus 6 over my 5. But look at the opposites here. You added 6 instead of subtracting. Hell, you multiplied by 5 up here, and here you're sort of dividing by the 5. Okay, so you'll notice a little bit of opposite type stuff going on. Which are ready for a fun one, so here we go. F of x equals 5 divided by x plus 9. I'm not going to lie, this one might be one of the more trickier ones. So replace the f of x with a y first. Then I'm going to swap that x and y around. So we're going to have x equals 5 over y plus 9. So y'all, here's the trick on this one. I can't solve that y while it's sitting in the bottom of this fraction. So remember, if I wanted to get rid of this fraction here, what can I multiply both sides of this by?
Y plus 9. Would it be Y plus 9?
Oh, that is perfect. Multiply both sides by the y plus 9. Good job. So we'll have a y plus 9 times the x equals the y plus 9 times or 5 over y plus 9. But y'all, we did that so we can come over to the right side and do a few crossing outs, right? Now, y'all, I'm going to tell y'all a little trick on this one. You got a y plus 9, and we're solving for this y right here being multiplied by this x, okay? So let's just write what we got. We got y plus 9 times the x. Only thing left on the right side is the 5. So y'all, let me tell y'all a trick. This is one of the one places where I probably wouldn't do no distributing, because I am trying to solve that for the y. So this x is being multiplied by the y plus 9. How could I move the x? How could I undo this multiplying? Well, y'all, you're going to come in and guess what? Divide both sides by that x. Because remember, if x is being multiplied by y by 9, if I divide that x, it cancels. Yo, all that's left over here is y plus 9. Do I even need my parentheses now? No, because we got rid of that x. So we basically have a y plus 9 equals 5 over x. How can this become a y all by itself?
Subtract the 9.
Subtract 9. Good job. So we got the y by itself. And y'all, we got a 5 over x minus 9. You're not combining that stuff. So that's going to stay a 5 over x minus our 9.
Aubrey.
And then now,
When I solved that, oh, I'm sorry.
okay, what was the question?
When I solved that, I did it differently than the way you just did it, and I still got that answer.
There's different, so they might have this one as a 5 minus 9x. There's different ways. I just think the easiest way
You
is to get,
did the x plus 9. I just did x plus 9 equals 0, like how you did it before on the last kind of problems we had where it was like a fraction. Do you remember that?
okay. But that's just finding domains, remember? Only time I would set that y plus 9 equals 0 is if I was actually finding me a domain. So the only other way you would see this, I think, would be 5 minus 5x minus 9 over an x they might do, but y'all math lab just wants this and be done. So what could have happened up here is if they distribute the x's. So let me show you the other way they might have done this. Math lab might do this. At this point, when I had the y plus 9 times x equals 5, they might have distributed that. So you get a y times x is a yx. 9 times x is a 9x equal to 5. Then they would come in and subtract 9x from both sides, because they're wanting to get that y by itself. So that'd give you 5 minus 9x. And then they would divide by the x at the last step. So that cancels. They would have their y. So now, both of these are divided by the x, but they would probably want you to do this. You cannot cancel these x's out because there's not an x in the 5, okay? If all three of these would have had an x, then you could have canceled it. So this is the second way MathWay takes it, but I hate doing distributing and then having to divide anyway. Okay, if you just divide, then all you're doing is subtracting that number and being done. All right, y'all ready for another one? But y'all, that's probably the trickiest one of them all, okay? So let me do one like 10. F of x equals x to the third minus 4. All right, y'all, first step you're doing.
Replacing f of x with y.
All right, keep me going.
Swap x and y.
So x will equal y to the third minus 4. So I'm going to give y'all a hint. The first thing I need to do is get this y to the third by itself. So we're going to add 4 to both sides. So I get an x plus 4 over here equal to the y to the third. Now, do y'all remember a while ago in support, when I had radicals, I used exponents to get rid of the radicals?
Yes.
Well, what's going to get rid of the exponents?
Square root.
Oh, what'd you just say?
Square root.
Square root, but this one's going to be a
Cube.
cube root on this one, okay?
Yeah, cube root.
There you go, but you got to use radicals. So I'm going to take the cube root of both sides. So really, radicals and exponents, if you can isolate them variables, they undo each other. Guess what, y'all? I can't do nothing with this. So that's going to stay a cube root, x plus 4. But y'all, guess what? That cube root cancels that exponent, and all that's left is our y. So we get f negative 1 of our x, which is our inverse function, is equal to the cube root of x plus 4. All right, y'all, watch this. F of x equals 3x squared plus 2. Now, y'all check out, this one says x has to be greater than or equal to 0. Now, the reason they're doing this, if you were to graph 3x squared plus 2, it would give you a parabola right here. But y'all, what they're saying is, hey, we don't care about this negative side. We only want the x values that are greater than or equal to 0. So if you only graph the right side of that parabola, it's just going to be one side, and that's going to make it 1 to 1. So that's all this x greater than 0 means, is that the graph only starts at the x value of 0 and goes on. We don't care about the negative side, okay? So y'all, once again, replace f of x with a y. And that's what they're going to do if they have to make them 1 to 1, okay? So remember, every one of these has been 1 to 1 so far, and if you was to graph all these, you would see that. Oh, what are y'all doing? Swapping this? So x equals 3y squared plus 2. So y'all, your goal is to get this y squared over here to be a 1y squared. So first of all, you're going to subtract 2. So I get x minus 2 equals 3y squared. Now, I don't want to do the square root yet because of that 3 in the front. So to make this 3y squared into a 1y squared, we're going to divide both sides by the 3. So y'all, I get an x minus 2 over 3. Those cancel, giving me my y squared. And y'all, last step. Turn this y squared into a y.
Square root.
Square root. So square root of x minus 2 over 3 equals the square root of my y squared. And y'all, guess what? I can't do nothing with that. So that's going to stay a square root of x minus 2 over 3. But guess what? That radical cancels with that exponent, making that a y. Now, here's what's nice, y'all. Guess what? On this problem, MathLab give you this, and they give you this. All you had to do was find out what went on the top on this one. So they're giving you most of the question, so that all I got to put on top is what? X minus 2. Okay, so MathLab, I guess, was sort of nice on that, letting you know that you need a radical on that answer. Okay. Well, y'all, guess what? We're down to one more, and we'd have knocked out 2 nights of work. Okay. So number 12, f of x equals a square root x minus 3. But y'all, I forgot how to do this, so y'all need to guide me.
Change it to a y. Y equals square root of x minus 3.
Uh-huh.
And then x equals radical y minus 3.
So now what's next?
And you got to solve for y.
Oh, I heard something.
Solve for y.
Uh-huh. So how you gonna solve that y? Because you got all this stuff under that radical. So what are you going to do to get rid of that radical?
Where?
Square it. There you go. So we got to square that x. And then we're going to square this y minus 3 under that radical. So that's going to leave me my x squared. Can't do nothing with that right now. On the right side, well, exponent canceled that radical, and a y minus 3 comes out. So y'all, I got one more step.
Add 3 to both sides.
Add the 3.
All right, I'm going to add that 3 to both sides. So can't do nothing here. That's just going to be
Plus 3 equals y.
equal to y. And then y'all know they're going to do this at you. And you're just going to put in your x squared plus 3. So to me, I like to do the inverse a little better than the composition stuff. And just remember, undo radicals by squaring, undo exponents like we had up here, undo these exponents by doing the cube roots, square roots, and all that stuff, okay? All right, let me pull that down. If I didn't know if any of y'all were still writing that. I'll pull that back down in just a second. All right, but y'all remember when it gets to the ones that say, hey, is this 1-to-1? If it's 1-to-1, find the inverse. Well, everything after 7 is going to be 1-to-1, and it will have an inverse. So y'all, I'm going to quit my share. Any questions over this? So we actually did stuff out of 9.1 support, 9.1 college algebra. Then we done some 9.2 support and 9.2 college algebra. So this was everything that was due by the coming up Sunday night, okay? Next week we got 3 more sections. 2 of them are really, really close related. One's solving systems of equations, and the second one is like goes with that one using word problems. After next week's 3 lectures or 3 sections, the next week I'm opening up test 1. We'll review Monday. Test 1 will be open from that Monday till the next Sunday.
Okay, speaking of that, test one will be over everything. Will we have a study guide?
Oh yeah, there's
Okay.
every test has a review quiz.
Okay.
Remember, the review quiz is like 5% of your grade, but you can go in and do that review quiz as many times as you want. The review quiz will have the same questions or type of questions as my actual test. So I haven't opened either one of them yet. I'll probably open them next week, get my quiz and my test. They'll both have 20 questions. Same order, same type of questions. All Math Lab's going to do is switch them numbers up, okay?
Okay.
So you really want to do the review quiz until you probably get at least a 70, 80, 90, whatever you want, because you can do it as many times as you want. The test, you only get 1 shot.
And the test is the review test, the review quiz is the test, just mixed up.
It's pretty much the test, yeah. But you'll do the review quiz and then you'll actually do the actual chapter test.
Okay.
So, yeah. So both of them do count as a grade, okay? And we'll actually do my version of the 20 questions that Monday that I open it. Okay. And then that Wednesday, we'll start the material for the next test 2. Okay. So y'all got this week, next week's 3 sections, and then the week after, that'll be like, let's see, 13, like the 17th or 18th, whatever that Monday is. That's when we're going to review for it. And you'll have till that next Sunday, okay?
Okay.
But they're not too bad if you just play with the review, okay? Alrighty, y'all. So this is the only time you'll really get hurt by a holiday on Monday. Labor Day always messes us up a little bit. The next break you are going to get will be like the fall break, and that's like the last week of November, whenever Thanksgiving is. Hey, y'all, so let me stop my recording.